the purpose of this presentation is, I guess it originated before Christmas when Magnus and I and a lot of other people in, I think it was the reference group meeting we had for Swebert, this big Swedish language model for Swedish authorities project, started speaking about, how we can make sure that all the results that we have from this project is shared in the best way and simply is possible to reuse for as many people as possible. And of course, we have already done, a number of really great projects and worked in this project. But a problem potentially is that the work that we do stays a bit siloed in the organization that actually produce it. And it's not really shared in an efficient way to other organizations. And I would say this even applies for organizations inside the Swebert project, where they do some new model, or they build a new prototype, or even put something in production. But it's hard to get an overview of what all the other partners are doing. And perhaps not as easy as one would like to simply collaborate, which we of course do, but we could, I think, do even better. But imagine if it's hard for us internally in this project to collaborate and share results. Imagine how hard it should be for people outside of this project, and when the project comes to an end. And that, I think, is an interesting discussion to have in really, how can we share the results and make sure that as many organizations as possible inside and outside of this project can reuse and take advantage of the results that we come up with. We will, of course, do the normal type of publications. We already publish a number of data sets. We will publish models and publish code repositories and papers and so forth. But the question now is, can we do something more, something in addition to that, that simply will help people reuse and operationalize these kind of results in the best way possible? So for some companies, at least, I would argue that it's not enough to simply have a data set that you can make use of. It's not enough to simply have like a model that is pre-trained in some way. It's not enough to have a code repository saying, here is the code, just do what you want with it. I would argue that most organizations actually still fail to do that. And of course, there are exceptions to this. And I think we've been really fortunate in this specific project to have really good partners and authorities like the tax authority and the employment agency and national library and so forth, that actually are able to even build models themselves, to build prototypes and even move them in production. But for most companies, I would argue that it's actually really hard to get started using AI, and even harder, even if they have a working prototype, to move that into production. And there is this kind of famous illustration. This is from Patrick Ecomo from DIG, the DIG agency, and he speaks about something called a prototype graveyard. And that's something that we see in most organizations today, I would argue, that they are claiming that they use AI, they are claiming that they have a prototype, and they sometimes even are claiming that they make a value for using some AI model. But in reality, they can perhaps make a prototype, but very few are able to put that into production, and it ends up being this kind of prototype graveyard. And that's something we really want to avoid. Another like funny example is this page called Killed by Google. And Google is probably one of the best organizations in being able to make use of the latest type of AI techniques. But this kind of fun page shows like hundreds of services, libraries, applications that they have that have been killed. And it's just amazing to see how many of them there are. And I would though say that this is a bit different when it comes to this page, because here are actually properly productionized applications that have been built, but later been terminated for some reason. And if you get to the point of actually being able to put something in production, you have reached a really, really good point and come a long way. And but I think it's interesting and see how, if you have that kind of success that Google and Facebook and Amazon and Microsoft and the big tech giants have, they have an immense amount of experimentation. And we don't see the prototype stage. We only see, when it actually moves to production and later potentially get killed. But if you can see, if they have this many, applications in production that's been killed, imagine how many prototypes they have. So yeah, interesting insight, I think. This is something that we spoke a bit about also in November last year. We had this big AI hearing in the Swedish Parliament. And we tried to go through a bit, what the potential is if we are able to use AI properly, and what the benefit could be for the public sector in Sweden and for the Swedish economy and so forth. And there is also like a national agenda for how we should use AI in Sweden. Perhaps not a proper strategy as they have in other countries like Finland and Germany, etc. But that's something that we really want to have in Sweden as well. And we're pushing for a lot in this kind of AI hearing. Just a recap perhaps about this Svebert project that I mentioned a number of times. We have a number of collaborators in this, and RISE is driving it with Magnus in the lead. And then we have AI Sweden, of course, Peltarion, and the Public Employment Service, and Tax Authority, and National Library, and others that are joining it. And I think it's really awesome to see that, especially given the immense research progress that we have seen in NLP in recent years, that we also want to really make use of it. A term you will hear me say a number of times is to try to operationalize AI. So that means that we can actually put something in production, or at least make sure that we have models and results and code and prototypes that can actually be moved into and integrated with the systems that the organization have to truly give an added value. I will not only speak about the Svebert project, I actually included some example project from another Vinnova project called, or we call it MedBert. It's formerly known as the Swedish Medical Language Data Lab, where also we from Peltarion collaborate with RISE, and it's coordinated by Sahlgrenska Science Park and AI Sweden, and other Swedish organizations are part of that as well. Also, some of the work I will be presenting now, which is, this is just a proposal. This is not finished work in any sense. So one of the idea now for this presentation is simply to see if we present the results that we have in this way, would that be of use? And if so, can we improve it in some way? And how simply can we make sure that we handle all the challenges that we have for building AI systems in best way possible, so that so many as possible can actually have value from it. And it's also built on a research paper that I and my colleagues in Peltarion wrote 2 years ago, called Software Engineering Challenges for Deep Learning. And that goes through a number of these challenges, and it's divided in a number of categories, like development and code, and for the organization and so forth. And yeah, you can read this if you want to see more about it, but it's trying to primarily identify the challenges and not really providing solutions. And here is another, like a small visualization I did. It's if you remember the old Kurt Olsson in Sweden, he was famous for making really nice maps that no one understood. And I think this is probably something similar. It's actually partly made to be a bit hard to understand, because I really do want to try to make it clear that to build an AI system is hard. It's a lot of things to consider, both from a legal point of view. You can see the red branch going up to top right. Also a number of data challenges, a number of model challenges, a number of challenges when it comes to software development and the code itself, and certainly a number of challenges in moving things into production. And last but certainly not least is the whole organizational aspect of how you introduce AI and data science into an organization in a good way. So this is also kind of a structure that I'm going to structure the rest of the presentation around. And I think it's easiest if I simply move into that and start exemplifying what I mean. So I'm going to go through one of them at a time, starting with legal. And the idea here is to, for one, present a number of use cases in a as concise way as I can, but then also to then present potential set of best practices. And now, once again, this is not an exhaustive and complete list of use cases. This is not an exhaustive and complete and even correct list of best practices. It's just an example of how we potentially can present some of the results that we have from this project to make it possible to reuse it in the best way possible. Okay, so here is one example use case. This is actually a paper that Peltarion wrote together with RISE. This is actually part of the MedBird project, but I think it's an interesting one that is connected to one legal issue. And one legal issue is, of course, privacy in data. And how can you handle that? So this one tries to use a technique to solve that problem. Instead of saying, some data cannot be used and you need to anonymize it and you need to do that and that, perhaps we can, instead of extracting the data, move the training process itself to where the data exists so we can avoid extracting it, and then try to train the models in subparts or in a federated way. So we never need to extract the data from where it was originally located. In this way, we can keep the data much more safe. But then there are a number of questions. How do you train these big NLP models in this kind of federated and distributed way without losing some of the performance aspects that they have? And this is a paper we recently wrote and showed some examples of how some models work well, but others, like the Dilbert, had some problems being trained in this kind of federated setting. But overall, I would say the conclusion from this paper is that, yeah, that actually does work. So federated learning in itself is something that is very much talked about in various different organizations these days. Perhaps even a bit overhyped, I would say, but still it's a very promising technique that can help us with one of the legal issues, which is privacy. And federated learning can be used for other purposes, but privacy, at least the one we focus on here, to simply allow companies to use NLP models even when there is sensitive data in it. If you want to know more about this, and you can see this kind of fact sheet. So I have a fact sheet that tries to go through a number of things and points for this specific use case. It talks about some legal aspects you can see, and it talks about some which models it make use of, and some kind of code aspects that were used in this work. And there is also a number of links. So if you want to know more about this, you can simply go to the archive paper that's published. You can see some presentation and videos that we have for it. And we can also, if you want to get in contact with someone that's worked with this to see, how can you apply it for your own use case, you can get in contact with some people, and you have contact information for that here as well. Okay, I hope you saw the overall idea. So now I'm going to go through a number of use cases and also some best practices. And I'm going to do it a bit quicker now, but here's another use case from the tax authority. And they had a prototype called Laganda. I'm not sure if you pronounce it properly. This is just my interpretation of it. So I hope if we have some people from the tax authority, please let me know if something that is written here is wrong. But the point is that this is something that can work with some legal aspect, which is how you handle event management in a smart way. This is more from an application point of view, so I'm not sure if it's properly should be placed in the legal category, so to speak. But once again, you have some kind of use case, how they can use human in a loop to simply make the process of going through different events and quickly answer them in best way possible, and using NLP techniques to search through different sources and simply make the process much more efficient by putting human in a loop together with AI. And once again, if you want to know more, there is a link to a presentation where you can see more about that, and also a contact person that you contact if you want to hear more how they did that and what the current status is. The tax authority also have another use case for anonymization, and this is obviously also related to legal. Another way to try to use named entity recognition techniques to try to automatically mask out personal information, which is an interesting approach to try to solve that. And you can see a link to a presentation and a contact person if you want to know more again. Here's another, I think, really interesting use case. This is from the MedBird project, but it's trying to help with one problem that the public dental service in Sweden have for being able to prescribe antibiotics. And as you may understand, antibiotics is something that we should try to minimize the prescription of to avoid building up resistant bacteria. And they have a huge manual process for this today. So they go through old prescriptions and the text from patient journals to try to see, was this a correct or incorrect prescription of antibiotics? And now we're trying to investigate if we can use NLP techniques to simply predict if they should have prescribed it, and in that way use, once again, human in the loop to find potential incorrect situations where you either prescribed or did not prescribe when you should have antibiotics. So once again, this is a project trying to use AI together with humans to make an important problem they have more efficient. And we use, a number of data sets for this. We use a number of these kind of multilingual models. But perhaps one even more interesting one is that there was a lot of legal work that we needed to solve to be able to start working with this. So as you may know, for GDPR, you need to have a number of agreements in place. This kind of DPA, or as you say in Swedish, it's called PUB, or personuppgiftsbiträdes agreements, etc. And I think, if someone has similar problems, then they can reach out to some of the contact people here to see how did we actually solve this? How did we get these kind of DPAs in place? And hopefully in that way, we can avoid some of the mistakes that perhaps other people have made and simply make it more efficient and share some experience that we have had from this project for a use case that may be similar in your organization.
Anders, there is a question. What is human in the loop?
Yes, so great question. And there is, some people have the idea that AI will only replace humans, and that we will only have automated, self-driving cars, or we will have completely automated chatbots, etc. I think, that will certainly happen in some use cases, and certainly in self-driving cars in coming years. But for most use cases that have the most beneficial value, at least that's the experience from me and from Peltarion, that it is when you find a use case where you use AI together with humans. So if you take this kind of use case for antibiotics, instead of manually having to go through hundreds of patient journal texts, we can use AI to simply do a prediction, sort all the journal texts, and simply recommend, go through the top 10 that is probably incorrect. So in this way, we simply aid or augment humans and have humans in the loop, while simply doing a process that took a long time before in a more efficient way. So that is what I mean with human in the loop. Cool. And then for each category, we want, of course, to try to define a set of best practices that holds in general in some way. And once again, this is just an example, and certainly not an exhaustive list of best practices for data access, but this is supposed to talk at least about the problem of accessing data in a good and safe way. So we mentioned federated learning as one potential technique that can help with accessing data without risking hurting some kind of privacy. Sorry, my throat is a bit poor. Without risking hurting privacy issues or risking any data safety problems. And another way that we're actually starting to work even more in MedBert is to, instead of extracting data and moving it outside the organization, perhaps we don't need a full-fledged federated learning use case. We can instead have something that we call in-house processing, which basically means that we have a machine inside the organization where the data is, that we give access to people that needs to work with it. So all the data is never leaving the organization, but we don't really need this kind of federated training part of it. We simply need to make people having access to the machine instead of extracting data outside the organization. And in that way, we can still keep the data safe while still training perhaps in more similar ways. But there's a lot of problems with this. And if anyone wants to try something similar, I would recommend that they use the contact information that we've seen on the use cases to learn more how we are trying to solve this in these kind of use cases. And I see I'm speaking too long already, and I'm going to move a bit quicker. But as you all know, GDPR and all these kind of PII, so personally identifiable information, is problematic if you have that in the data, and you need to really make sure that you have the right agreements in place. But that said, I would really try to once again say, don't be afraid to do it. Don't be afraid to use NLP. Don't be afraid to use AI, even if there are PII in your data. It is possible to solve. We have done it in a number of use cases. You can see a number of examples in this presentation with links. So if you simply know what to do and can learn from some of the other work here, it's still very much possible to make use of AI and data, even if it contains PII. Okay, so moving into the other category of data. And once again, I'm going to go through a number of use cases, and I'm going to do it a bit quicker now. And here is one from the Employment Service, where they have basically data from job ads that organization put up, and they have, of course, resumes from people, and they have a problem of trying to basically structured or enrich, as I call it, unstructured data with job ads to a more structured approach where they can understand different aspects like job titles, skills, and work experience, etc., from the job ads. And they have been working with a number of techniques, and you can see in the fact sheet, what type of data they are making use of, what type of models they have used, some information about the code, and they even developed this kind of really nice library called Near Black Box, so named entity recognition library that helps both with training models and using the models for this type of name entity recognition, but also for annotation purposes. And you can see some links for more information and contact people at the employment agency. Here is another one. I'm not sure if I should have included this because it's not really related to text, but it's something that we launched yesterday in Peltarion, and it's more related to a company called Emexi. And I think it's interesting because it revolves around annotation. And I think annotation is an area that is not properly researched and explored yet. And actually, even it may sound easy, you just need to tag a piece of text to whatever category it should have, or whatever kind of named entity it should have, or some sentiment. But being able to do that in an efficient way is actually surprisingly hard. And there are a lot of techniques that can make this process much more efficient and much cheaper and much more effective as well. And this is something that we have been working with a bit in Peltarion, and for example, using active learning techniques to make that happen. And in this case, it's actually using images and then trying to identify potentially malfunctioning production from 3D printers. And then we have a hackathon that's where people can basically play around with this and see, how can be the model that are able to identify these kind of anomalies in the best way possible. And once again, you see, what type of topics we have. You see links with an app that actually is a demo app. You need a login for that, but you can contact the person, Tim Ipster, that is actually part of this webinar, I think, as well, if you need more information about what's happening here. Another interesting project we did a while back was, it's also related to data and when it comes to annotation. And in this case, we wanted to see if we can measure the quality of music from sound. And then we had this kind of generative adversarial network approach to do so. But to be able to do that, we also needed ground truth. And I think this is the most interesting aspect of this. How do you gather ground truth data from something as subjective as music quality? Well, in this case, we've made use of a service called Amazon Mechanical Turk, which basically is a service that helps you make use of human workforce, so to speak, where they have to tag a number of sounds, in this case, with ratings. And then we can see how well we can make a model learn how to predict the quality of music using GANs. And it actually turned out it's not that easy as you sound. It sounds easy, you just use Mechanical Turk, you connect the data, but there is a lot of issues that needs to be considered to make this work properly. And I think this is a perfect example. If someone wants to use something similar to annotate something, I would certainly recommend that they reach out and avoid doing all the mistakes that we did when we initially tried to do this. Again, links and some contact information. And for data, here is a very small set of best practices. Of course, we will, if you think this is a useful type of presentation of results, we should extend it more and make sure it's more complete and more correct. But as an example, for data annotation, active learning can be a really useful technique to make that process much more efficient and more high quality. the employment agency has a really nice tool called Near Black Box that can help you as well for being able to do similar things that they did. So I would recommend that they look into that if they want to do something similar to what they did. And also active learning, especially for NLP, is actually surprisingly hard. It's something we're working a lot with right now and preparing a paper for in Peltarion as well. Okay, so let's move over to another category, which is models. And here is another interesting model, and I think it can't be overstated how impressive, or I was actually surprised to see that the employment agency were able to build this model very early on. I think it was actually even slightly before the Swebert project got started, but they trained up a new BERT model based from Swedish text from Wikipedia and published that. And of course, this is really great to see that they were able to do. And they are continuing working with that. And if you want to make use of this, to, for example, use it for some specific use case you have based on Swedish text, but you need to fine tune it for doing some kind of categorization of incoming emails or something that you have in your company, then you can try to use their pre-trained model that they have and then fine tune it in your own data. And hopefully then you have a human in the loop AI system that can really make your process go much more efficient. Once again, some links with more information to the code repository and contact information. We have the National Library that also built a number of Swedish language models and pre-trained BERT models. And they could also make use of all the huge amount of data they have in the National Library to build these models. And they built not only BERT, but also Albert. And I think they're preparing now with Magnus and others to also build an Electra-based version of this. So similar to the other model, if you need a model that you want to fine tune for your specific use case, if it's question answering, classification, sentiment analysis, name entity recognition, or summarization, or who knows, then it could be a good idea to talk to these people and see, can you start from this model and then fine tune it further for your problem. Another awesome paper that is also hard to overstate how awesome this is, but something from RISE, they built a model called CT-BERT that can be trained to do textual similarity without requiring annotated data or any annotated data at all, and taking a contrastive learning approach for that. And it works surprisingly well, even outperforming sentence-BERT and other state-of-the-art models for similar use cases before. So once again, if you want to do text similarity and you have perhaps not annotated data, but you have at least some Swedish data, then this could be a great model for you to look more into. And see the links to the paper and contact Magnus if you want to know more about this. We also had another paper that Peltarion and RISE did together, and we or Tim, that I think is on this webinar as well, simply said, why not simply translate? Why not, we don't have a lot of annotated data in Swedish, but we have a lot of English annotated data set. Can't we simply use machine translation of the English data sets and then train models based on that? And it seems to work surprisingly well. And if you want to learn more about this, you see some links and contact people for that as well. Another thing that we have been working a lot with in Peltarion and have a PhD looking into exclusively is how to do explainable predictions. And we have this in a number of projects, but one thing that the PhD student is looking into, and we're going to publish something shortly about, is how we can take a model like T5. And T5 is this transformer-based model that is basically state-of-the-art for most kind of NLP tasks, and it's also generative. So because it's generative, it can not only do classification and regression tasks, it can also generate text. And I'm not going to say GPT-3 here, but you can think GPT-3. But in this case, it means it can actually generate an explanation. So what you see below here is that you can, for example, ask the green bubble to the left saying, explain sentiment, and then some piece of text. And the model will for one, do a prediction of the sentiment, which says negative to the green up to the right. And then it says explanation colon and explains the negative sentiment, saying the acting was terrible. And this is actually kind of magical almost, that it can not only make a prediction, but actually generate natural language to describe why the model thinks the prediction was, in this case, a negative sentiment. And we're looking into moving that to Swedish now, and also how to transfer between domains, like medical domains and whatnot. Yeah, I see the time is also running away. This is another project we did about question answering, and this is more related also to how to adapt it to specific domains, such as a medical domain, or if it's legal domain, or it could be telecom domains that have a lot of special words that may not exist in traditional natural language corpus like Wikipedia or Kungliga biblioteket. And then you can still use the pre-trained models, but you need to adapt them. And this is, you can see some links if you want to know more about how we experimented with this, and a blog article with some more details. In short, once again, not by any means an exhaustive list of best practices for model training, but at least here are some examples. And if you think this is a useful way to summarize some best practices, we should make sure to have more of these and a better and more correct way of framing them. But of course, transfer learning is standard practice these days and should always be used. We can do fine-tuning on models, sometimes even without annotated data, as the CT BERT example. And something that I really like to push as well is that these kind of multilingual models, especially the later ones, perhaps not the first one didn't work that well, but the recent ones like XLMR, and especially this very recent one, it's only a few months old, called MT5, work surprisingly well, even better than monolingual in some use cases. And the nice thing with them is that you can fine-tune it on English and then apply it in Swedish without having any Swedish annotated data at all. And they're also generative, as we said before. Yes, and what else? Perhaps the last point here I think is worth mentioning. Excuse me a second. It's not sufficient sometimes to have something pre-trained for just Swedish. If you look into, for example, a medical domain or a legal domain or a technical domain of some kind, they have a large number of very specific words. And for example, for patient journal text, they have a language that is not even grammatically correct. And if you start to adapt the model to that, so you can take the pre-trained version and just do further pre-training on that type of language and adapt the vocabulary. And if you do that, you can see to the bottom right a graph how the model language model accuracy, the mass language modeling task, improved by doing so, going from like 60 over to 70% accuracy. So this is a really big increase. So that can be useful to do. Okay, so code. Another use case. This is once again something from the tax authority, being able to classify documents as they come in. And once again, they had Swedish annotated text that they can have. I believe in their system, and we have to double check with them, but I believe they had like a feedback in the front end that they built to be able to specify how relevant a piece of text is for a certain category, and in that way continuously also improve the model with the feedback data you get in the pilot itself. I think that's a really nice example of how you can generate the data yourself while working with it. We also have an example here from LTU, how they built a chatbot to help people with depression. And they use a bit of a different type of model, so these kind of shallow word embeddings, but we're able to make that work surprisingly well. And you have a link with and contact information for that here as well. Here's another cool little project we did in Peltarion as well, which was if we wanted to, we basically want to explore how well does these multilingual models like XLMR work. Well, then we collected data from the Swedish parliament and for motions that comes in from different Swedish parties, political parties, and tried to predict, simply given us a couple of sentences from these motions, can we predict which party that text came from? And you can see the confusion matrix here, and it's actually surprisingly good. Then you can take the embeddings that you get from these type of models and try to see how connected are different Swedish parties to each other. And we can see that the yellow one, which is Sverigedemokraterna, is rather, or very far away from Miljöpartiet, for example. And if you take like, yeah, I guess Liberalerna, they're in the middle or a bit all over, and other are, you know, separate from each other. So it's kind of interesting and worked surprisingly well. And you can see some links and more information in blog posts, etc. if you want to know more. Yes, another, I think I skipped this one. It's a traditional old example of text similarity. And yeah, I think I skipped that one. Here's another example from Peltarion where we try to do topic modeling. And topic modeling basically means that given text without any annotation, can we try to understand what the text is talking about? So there is the general problem of, so that's called topic modeling. And we want to explore, can we make use of these kind of transformer-based or BERT-based models to have a more semantically correct set of topics that we can identify in pieces of text. And this was from a master thesis project that we did, and you can read more about that in the presentation and the report that we have. And yeah, what we also did is we want to basically see how the topics change in popularity over time. And this was for a big, one of the biggest journals, scientific journals that we have, called Journal for Cleaner Production. And you can see to the bottom left how some topics were moving up and down in popularity over the last 20 years. Here is another example that are speaking about similarity once again. I think it's interesting how we can use that to also like highlight in PDF documents where you want to find information. So in this case, you want to have human in a loop once again, where you need to go through an RFP. An RFP is basically a set of requirements that you need to fulfill, and they need to answer that to a customer. So they, if one want to simply, instead of manually going through all the requirements, having an AI that simply suggests, you know, this was so similar to a historical RFP, so I think you should answer in the same way as you did before. But what you can do in addition to that is also to try to find answers in large product description documents. And then you can simply search through that using these kind of BERT-based techniques, like semantically understanding that and highlighting these PDF documents, an area where a potential answer exists. And you see a screenshot of how that works here. And you also see some links and contact information. Yeah, here's another one. I think this is interesting, especially because it's, when I actually spoke to Tim about this, who was one of the people working with us, he said, you know, don't bring this up. It's too simplistic. It was a super simple prototype. It's not really interesting, but I think it is interesting. And it's interesting because it's amazing how fast you can build something if you do it the right way. So in this case, we integrated with an API from Microsoft for doing text-to-speech. So we can take audio and translate that into text. And then we can make use of a multilingual model like XLMR to simply find similar phone conversations in the past. And it simply worked surprisingly well. And you know, if you can reuse the knowledge that you have, this is, I think, a great example of how quickly you can build a prototype that seems to provide value. Okay, trying to speed up once again. Here are some examples of best practices, not a complete or exhaustive list, but you know, one traditional and a very common tip is to fail fast. So what that means is it's better to try out 10 different use cases and fail quickly if something doesn't seems to work out, and then find the one of the 10 that actually do work. That is usually the best way to do that. And also look into, you know, be sure to integrate if it is possible. Don't build everything from scratch. As we saw just before for the phone call prototype or example, if you do this properly, you can do rather advanced things very, very quickly. Yeah, similarity is useful. I think we already mentioned that and seen that a number of times. Human in the loop, we also spoke about that, how important that is, and especially in the beginning. If you sometimes see that an AI system is always doing the right thing and you really don't need the human in the loop anymore, great. But don't start with that. Start at least with the human in the loop to see and make sure that we simply make the process more efficient with AI and humans working together. And also, I think, I'm not sure how many times we heard from companies from Peltarion where they say, well, we have this GitHub repo of XLMR or MT5. We can simply use that and integrate that into our system, and then, everything is solved, right? And no, it's not. And you would be surprised, if you worked as much as I have with this type of horrible code bases that you get from these research teams, they are not ready for production. And they move very quickly, and they are buggy, and they are not something that you should put directly in production unless you really know what you're doing. So a warning sign for that. Okay, and talking also about deployment a bit, and here is another system that the tax authority did for doing machine translation that I believe they have in full production right now. We did a thing for Riksbanken, the Swedish central bank, where they wanted to basically track in real time corona sentiments or toxicity as we measured here. So we could basically take real time tweets and do a sentiment analysis based on BERT model, and then feed in real time into a dashboarding system called Superset that Riksbanken have. And you can find a link to that and more information if you want to know how that was done. Yeah, here's another system that we put in production with one of the biggest market research company that we have in the world, called Ipsos. Sybase is another company that also made use of the Peltarion platform in this case and integrated that into their system to basically be able to identify melanoma in a non-invasive way using time series data that they get from this kind of pen that you see in the picture here. And yeah, I'm not sure if I should mention, this is actually a side project that I helped some friends of mine doing, but I had so much learning from this because it has a really advanced annotation system, not only using active learning, but doing a lot of other tricks to find the specific data points that need annotation given a confusion matrix. So sometimes you don't want to only know which one that are the most the least confident predictions, but you actually want to see sometimes where it's most confident, but it's a misprediction. So if you, I can speak more about this. I think this is a cool system that is, for one, actually doing continuous model retraining all the time and deployment, and it's auto-scaling, and it's real-time monitoring and notification. But especially the annotation system here, I think is interesting to go further beyond just active learning and find problematic annotation points that may have been, for example, wrongly annotated in the past, and how do you detect that and things like that. Okay, so best practices going to production. Some kind of general tip that we do from Peltarion in building these kind of systems is trying to divide them in potentially like 3 phases. So we have one that we call basically a prototype phase, where the idea is to be able to very quickly experiment with different data sets and models. And it's basically done by extracting data from the system. It's done by data scientists and for data scientists. It's not really being put back or integrated in any way. It's just building perhaps a small prototype that is completely separate from the real system. But in that way, you can really quickly experiment and see what potentially works and what does not. Then we can move into like a semi-production state that we call a pilot, where you can integrate perhaps the data pipeline you have in the system with the model that you have, make some predictions, and have real domain experts in that system evaluating it. It does not mean going to full production because that's a lot of work, but it's the minimal way where you can at least integrate and then take some shortcuts to be able to integrate into the system that they actually do have. So you can have a proper evaluation of domain experts to see, what they think provides value or not. And I don't think I can stress this enough, how important this is, because usually the feedback you get from these kind of pilots doesn't really have to do with the performance of the model. It's others, like small aspect of, how the front end works, or, can you change that, and then suddenly they're super happy with something. So really important point. And then moving to production basically means end-to-end system integration with all the data coming in and also going back, and continuous iterations, of course. And all these kind of 3 phases you iterate between. It's not like a, of course not a waterfall process, but you start off with a prototype, you move, if you find something promising, into a pilot, and then you can move then to a first MVP in production, and then you go back and iterate. Yeah, I think I skipped the rest because of time problems. So the last category is organization. And unfortunately, I didn't find some good use cases because of lack of time of preparing for this presentation. But I at least added some best practices here when thinking more, how can we adapt the organization to become more AI driven? And from my days in Spotify, the first point here about embedded data scientists or not is something that we discussed so many times. And and the core idea is simply, should you have a centralized data science team that do all the data science work, or should the data scientists be embedded, for example, in product teams or some other departments of the organization? And there are pros and cons with both. There are a clear risk of conflicts if you, for example, only have data scientists in a product team, and a single data scientist or analyst have to fight with the product owner to be able to prioritize really what we should do. And that's a clear risk. But it's also a lot of pros when you have a much faster turnaround time and a better understanding of the domain and the product you're building if you have data scientists embedded in the team. I would still argue that the best way to start, if you have basically no centralized or no data science team at all, then you need at least some kind of critical mass, some set of people that can help each other to get started and do knowledge sharing, and be a set of people that quickly grows up the knowledge that you need to have to be able to understand how to work with AI. Then you can start to spread up and build up like a hybrid organization, which we did in Spotify, where you have both embedded people but also centralized people, and the centralized take more of a long-term research focus, and the other have a more product-oriented focus. And in the end, I would say, if you reach the level, no one can reach a level, I guess, that Google and Facebook and Amazon and Microsoft have, but if you move towards them, I would argue that the true scaling of using AI occurs when you have different departments and domain experts in the organization that can, by themselves, start using AI and not be blocked on some kind of centralized team that needs to do everything for them. So when you enable domain experts to use AI, that's when you truly start to scale AI in your organization. Cool. Yeah, and here is more about knowledges and how you build up knowledge, and you need to have that throughout the organization. It should not just be in a centralized data science team, it should be in any kind of team. And there are these kind of basic understanding of AI, like Elements of AI, that's a free course that everyone can take. It's very important that you have a proper understanding and perhaps a sponsor in the management team for this as well, to have them understand the potential and what you can do if you do it right. I think it can be a good point to read, for example, this essential AI handbook for leaders. Don't fall in the trap of the analytical ladder, where they think you have to first build analytics systems. You first have to have like a data-driven organization where all the KPIs are being fed from all parts of the organization into some centralized dashboard system. And then when you have that, you can move to something that some people call advanced analytics. That's a very dangerous view. You can actually start making use of AI directly, even if you don't have a full-fledged analytics team that can do like business intelligence. So keep in mind that AI is different from analytics, and you can do both. Both are important, but you can do them in parallel. And if you want to reach what Google and others are seeing here, you see the Google CEO in the top and Microsoft in the bottom. It's truly when, if you want to be an AI-driven organization, AI should be not like a centralized oracle in some way. It should just be a natural component in every part of, the products and services you have. And that is what they are doing. Cool. So that was a very quick walkthrough, which is once again not exhaustive and complete and potentially incorrect in some examples. But I hope you saw the point of we want to have a concise set of use cases that instead of writing a long report, try to go through everything they did, instead just give some small hints on what kind of topics they were tackling, and then have links to more information and people that you can contact. And yeah, I guess this is the question I would like to ask all of you is really, is this a useful way to present results from projects like Swebert? It's of course not, that's going to replace, what we will do anyway, which is publish, papers and data sets and models and code repositories, but it could be a complement. The goal is that this in some way or form, having them in a presentation format like this may not be the best because it needs to be sequenced, and some of the use cases connect of course to multiple categories, but the presentation needs to be in a sequence, so then it's not perhaps the best format. Perhaps more of a website where they can link all the use cases to the categories and challenges that they tackle could be a better format. Yeah, I think I stop there. I'd like to just push in closing to some upcoming events that are going to happen. And I've been part of also the Swedish AI agenda that's been going on for about a year. And one of the output that we have from that work is to come up with like 23 action points that hopefully can guide the Swedish government in what actions we can take to simply accelerate and make the best use of AI that we can. And one of the action points is actually to build up a use case factory, as it's called there, which is not unsimilar to basically what I were presenting here, like a set of small use cases that is described in a concise but hopefully informative way. And that can inspire companies to what's possible to do. And if they want to do something, where can they read more and get in contact with people that they can obtain knowledge from. There's going to be a formal or official launch or digital launch of this on February 23rd. So here is more information about that, and welcome to that. I will be taking part of that as well. And another and the last thing is this area, which some people have coined as AI engineering. I think it comes from John Bosch, the famous scientist from Chalmers. And this is an area which basically combines or is in the intersection of software engineering and AI. And we basically have a new workshop that's going to be held in May this year, where we want to basically understand how we can, from a research point of view, build up knowledge in making this process of building AI system more efficient. And I think it's something that we should have done for a long time back. But please, go to this website, and I think the deadline has just passed, but you can still join that workshop, and I'm part of the programming committee there as well. So just reach out to me if you want to know more information about this. I see the time is now exactly 3 o'clock, so I think this is a perfect time for me to stop. And thank you for all your attention, and I'm happy to take any questions you may have.